I hope that everybody is going to really learn something out of this session. This session, I'm going to really just cover the fundamentals of blockchain and cryptocurrencies, which I'm going to focus on these three areas. I'm going to focus on these three areas. There's a basic introduction to blockchain and cryptocurrencies, then a basic introduction to smart contracts, consensus protocols, and mining, and then also cover something on wallet mechanics and security measures. So we will not be able to do any activity, but I want to start with this quote, at least one of these quotes from Vitalik Buterin, that says that whereas most technologies tend to automate workers on the periphery doing manual tasks, blockchains automate away the center. Instead of putting the taxi driver out of a job, blockchain puts Uber out of a job and lets the taxi drivers work with the customer directly. So what Vitalik is saying is that Uber, as we know it, is a centralized organization. So Uber gets drivers that then signs up on their platform to offer the services to the public, but then they deduct, or rather they get a fees, or that they pay a fees for using that platform. But blockchain really does not bring the aspect of Uber relating with the driver, but blockchain focuses on decentralizing the entire power, decentralizing that authority or decentralizing that organization entirely in a way that the driver then just needs to relate and work directly with the customers. Yeah, and that is, if you know about decentralization, that is really disruptive. And I'm going to really explain in the coming slides about that aspect of decentralization. So what is blockchain? In simple terms, blockchain is a decentralized, distributed digital ledger technology where similar records of transactions are kept and updated across many independent computers so that the records cannot be altered without the approval of the network participants. So I guess if I use an example, it becomes easier for you to understand. And there is this one example that I like using, and I'm going to use it today as well. If you can see the diagrams, both diagrams depict an image of multiple computers that are interconnected in a way. So like in this meeting today, assuming that this was a seminar, perhaps a government or a stakeholder seminar that has some attendance allowance, assuming that the attendance allowance for this meeting was maybe $1,000 per person. Yeah, that's a meeting you don't want to miss. So if I just want to get the name of one of you, assuming that okay, I can see Asana. Assuming that Asana was assigned to be the head or to be the facilitator of this meeting, and Asana is supposed to take the names of everybody who comes into this, who joins the meeting, and it is that list that will be used to then distribute the allowance. So that if you're not in that list, you will not be able to get any allowance. Yeah. So assuming that Asana has some issues with me, has some grudge with me for any reason. So Asana decides that he or she will not put my name on the list. That same list is what will be used by the owners of the meeting to facilitate the distribution of the allowance. If I'm not on that list, there's no way I can convince the owner of the meeting to actually pay me or give me the allowance. Now, Asana can decide to omit a number of names of people who are not friendly to him. But interestingly, when we use blockchain, what we will do is the role that Asana was playing, that authority that Asana was given, will now be given to each and every member in this meeting. So that each and every member will now keep a ledger, will now keep a list of transactions. And those transactions are the attendance. So the list of the people attending, we see those ones are the transactions. So when each of us now can keep the records of everybody who is attending, so that I write a list of everybody who is attending, you also, each of you also write a list of everybody who is attending. What will happen is all of us will have the same list if we actually faithfully write everybody's name who has attended. But if Asana and maybe myself, Benjamin, do not like some of you, I may decide to omit some of your names from the list. If I do omit some of your names from the list, what will happen is that at the end of it, the owner of the meeting, when he collects all these lists, he will decide to go or adopt the list that is the longest, the list that is the most dominant, which means the list that is consistent across most of the attendees. So the list that has some of the names missing will not be adopted. Yeah, and that is how blockchain is. It is decentralized. It is distributed. So we distribute the authority and we distribute the ledger as well. So the authority, we distribute it because it is the authority that is responsible for validating transactions. For you to enter any building or for you to access any controlled environment, there is somebody at the door. That is the authority. That authority will need to validate the transaction of you entering that building, the transaction of you accessing that system, the transaction of you perhaps joining this meeting. There is a centralized authority that has to validate that transaction. Now, that centralized model has a weakness that makes then non-centralized models like blockchain, or rather decentralized and distributed models like blockchain become more useful and more secure. Now, what is the problem of centralized systems? You look at the three diagrams that I have on my screen right now. If you see the centralized diagram, there is a point at the center, and all other points would depend or are connected to this particular point at the center. Now, if we compromise that one center, that one point at the center, what will happen is we would have compromised the entire system. That's why it is always easy to hack a centralized system than it is easy to hack a decentralized system. Because for a decentralized system, there are multiple authorities. For you to successfully hack it, you have to hack and compromise all those authorities. But for a centralized system, it has what we call a single point of failure. This single point of failure, you just need to compromise that single point. Once you compromise that, the entire system becomes compromised. Now, decentralized and distributed systems are more secure because you need to compromise multiple parts of this network for you to successfully compromise that entire system, of which something that we'll cover later under consensus protocols, if you have a strong consensus protocol or a method through which the nodes or through which the participants reach a consensus on that network, then it becomes almost impossible for you to compromise that system. And a good example is the Bitcoin blockchain network that uses the proof of work consensus protocol, which becomes so expensive for hackers and almost impossible to compromise for hackers, because then they have to really unmine and unwind really all the transactions that have already taken place. So just maybe another example of the difference between centralized and versus distributed ledgers. And I'm giving another example because this is an important aspect, concept that if you understand about blockchains, then it will be easy for you to understand where this technology can be applied. Because most people really think that the only use case of blockchain, or rather they think that the most use case of blockchain is only cryptocurrencies. And cryptocurrency is just a small part, a very small part of what blockchains are and where you can actually be able to use blockchains. So if here I give an example of a bank, yeah, a conventional bank system, the way it works. So you have, when you have an accountant, an internal accountant, what normally happens is that you have an internal accountant. For a regulated company, you have an internal accountant, you have a bank account for the company, and you also have probably a listed external auditor, sometimes even an internal auditor. Yeah, this is now when you come to accounting. Now, what normally happens if an accountant has kept a ledger of transactions that they have done that month? During that financial year, before financial statements are produced, the accountant normally does a reconciliation with the ledger that the bank is keeping, so that they're clear about the finances that have been used and the finances that should be still be available within the bank account. So the ledger that the accountant is providing should rhyme the ledger that the bank has. So they have to keep two ledgers. And also they have to get a third party, what we call a trusted third party, which in this case is normally an external auditor, to come in and check if this accountant has actually been doing the correct work, has been doing his work genuinely, and therefore has not been compromised, or rather has not fraudulently added some transactions to the ledger that he is producing as the financial statement. Now, when you go to a distributed system, something that probably we may cover another day is the concept of the triple entry accounting. The triple entry accounting is where they're trying to introduce a third sort of mirror, a third entry that mirrors the transactions of a double entry accounting. And this third entry is entered, or rather mirrored, on the blockchain, which is immutable and which is tamper-proof. So it will be difficult to compromise. So if you look at the distributed ledger model on the right side, you'll realize that the nodes are spread, the node A to E. They're all linked together, and none of these nodes has more authority than the other. Now, this is the true model of how a blockchain, a public blockchain, works, and how a public blockchain is modeled, where the nodes or the validators, or what we call the miners, all of them have the same authority, and this same authority makes each of them in a position to validate transactions and authorize any transaction. Now, moving to the next slide, I just want to show how a simple Bitcoin blockchain transaction works, or how you can do a simple transaction on the Bitcoin blockchain. So A wants to send some Bitcoins to B. What does A need to do? So there are two people who want to transact. Yeah, both of them have a cryptocurrency wallet, and in that manner, that cryptocurrency wallet must be compatible with the Bitcoin blockchain network, which most wallets actually are compatible with the Bitcoin blockchain wallet network. So if you want to A wants to send 1 Bitcoin to B, what does A do? A will need to ask B for B to send them their receive wallet address. Yeah, it's like when you want to send me an email, you have to ask me for my email address. So my email address becomes my public key. Yeah, it is what I use to receive. It is what I use to interact with the public. Yeah, but for you or for me to read the email that you've sent, I have to have my private PIN or my password, which is private to me and personal to me. And that is what I use to spend, or rather to read whatever is in that email. Now, in Bitcoin blockchain, we have public and private keys. Now, the public key is what you use to interact with the entire, with the other blockchain or wallet owners. So B should send a public or receive address to A. Now, A, once it goes to to the wallet, he opens the wallet, enters this public, receive address, enters the amount of Bitcoin, which is one that he wants to send, then click send. When he clicks send, that transaction is broadcasted, as you can see on step 3. It is broadcasted across. It is broadcasted across the nodes or across the network. Now, all these network nodes or participants will be able to see the transaction. Excuse me. Now, when they see this transaction, all they need to do is to check, does A have enough Bitcoins to send to B? If A has enough Bitcoin to send to B, then they can confirm that transaction. Yeah, and when they confirm that transaction can be able to move. If you can see now in 4, there is the ticks on all those nodes, which means they have confirmed that transaction. Now, they have validated that transaction. Now, once they have validated that transaction, in 6, you see the money now moves from A to B. Now, the Bitcoin has been deducted from A's wallet and been moved to B's wallet. You realize that this role of validation is what is normally played by central institutions like a bank or like a mobile money service. In Kenya, we have what we call M-Pesa, which is a mobile money service. So you get somebody's mobile number. I get your mobile number, and I use my app and use your mobile number to send you money into your mobile wallet. In that particular instance, when I click the send, and this applies for any transaction, whether it's a Visa card transaction, the moment you click send, that transaction is normally really not broadcasted, but that transaction is sent to the database, or is sent to the main company, the validating company. If it is Visa, it is Visa. If it is a bank, it is that particular bank that validates that transaction. Now, their system has to verify whether you have the certain amount, sufficient balance in your wallet. If you have sufficient balance in your wallet, they will approve that transaction, and that amount will then move to the other wallet. Now, I'll just cover this quickly, talking about the different types of blockchains. So we have public permissionless blockchains, we have public permissioned blockchains, private permissionless blockchains, and we have private permissioned blockchains. So when you talk about public permissionless blockchains, these are blockchains that anybody can join. Yeah, you can, for instance, the Bitcoin blockchain, you can join if provided you can be able to. For instance, right now, if you want to become a validator on the Bitcoin blockchain network, yeah, you can just be able to buy a validator or a mining rig, a Bitcoin mining rig, or set up a miner and be able to just start your validation process. Yeah, it is there for anybody, provided you can afford to set up the equipment. You don't need to really. It's not for a click of a few people. Yeah, it's anybody who is willing to join. So the fact that it is anybody these blockchains normally, especially because, like I've said, Bitcoin in particular, because it uses the consensus protocol of proof of work, they're highly secure. Yeah, it has more security compared to other blockchains that are not permissionless. Talking of public permissioned, these are blockchains that anyone can join and read. So when you talk about blockchains, we are talking about read, write, or commit. Yeah, those are the various permissions. So a public permissioned blockchain, anyone can join the blockchain, anyone can read transactions, and anyone, no, that is a public permissionless. Anyone can also commit. So in a public permissionless, anyone can read, can join, can read, can write, and they can also be able to commit. Now, when we talk about public permission, anyone can join, anyone can read, but they always leave some permissions, or rather some access rights to a segment of you that will be permissioned. Yeah, and a good example of public permission is a Ripple or EOS. Then public, or rather private permissionless. This one means only authorized participants can join, can read, and can write. So for you to join this blockchain network, you have to be authorized. But once you have joined, you have the permission to do anything with everything that is allowable within that blockchain network. Yeah. Then private permission, here they regulate joining or entry of participants and reading. They also regulate whatever you can commit within. So they regulate joining, but once you've joined, they also regulate who can actually participate, who can actually transact within that network. And these are important really only when we get to the point where you're looking at the various ways through which different entities can be able to adopt blockchain or implement blockchain in their unique aspects. For instance, the way a government needs to implement blockchain may not be the same way as a bank may need to implement blockchain. There is the data privacy levels, security levels may vary. And because of such reasons, therefore, they may need to use different types of blockchains to meet or to serve their purpose. Also, just to brush on this, areas where blockchain can be used. We've talked about almost every industry being centralized, and blockchain being decentralized has key features. The key features of blockchain that makes it really instrumental in any industry is blockchain is decentralized. Blockchain is also transparent, which means it provides transparency. And just to give an example of that transparency, for instance, transactions that have happened in the Bitcoin blockchain, you can be able to check all of the transactions that have ever happened in the Bitcoin blockchain since inception of the Bitcoin blockchain in 2009. For you to check that, you go online and you search what we call the Bitcoin Explorer. Now, on the Bitcoin Explorer, you can be able to check all the transactions, even the one that has happened just now, a few minutes ago, the one that happened yesterday, all of them. You can be able to check all those transactions. Of course, the wallet addresses will be hashed, but you will see how much of Bitcoin is moving, is changing hands every minute or every second. So you see different ways. I mean, there are several ways where the blockchain can be used, particularly other blockchains that like the Ethereum blockchain or the Binance smart chain, which have the flexibility of smart contracts. The Bitcoin blockchain do not have this flexibility of providing the smart contract capability. So talking of digital rights, issuing digital rights, it can be used for on the e-commerce platforms, or any platform where you're thinking of digitizing the process or automating the process and decentralizing some authorities, which means you reduce the amount of bureaucracy on that system. A good way to reduce that bureaucracy and increase transparency is to rely on a decentralized platform like blockchain. I can give you a good example is in, for instance, this 5 ways in record keeping. I think that is one really good area where blockchain would be used in healthcare record keeping, in land title deeds, and ownership. Ownership, whether it's a property ownership, whether you're talking about a digital asset ownership. Like right now, the industry talks about what we call non-fungible tokens, or also known as NFTs. Now, non-fungible tokens can be used for ownership. You can be able to own an NFT online. So that is a blockchain-based record keeping where you can be able to trace the ownership tree of a particular NFT. Who was the first person to generate it? Who owned it next? Who else was it sent to? And what is the value changes across these ownerships? Now think of that when you talk about, for instance, the value of vehicles. Think about where you have, you bought a Tesla vehicle. How will the value or the price of this Tesla vehicle and its features, or rather, particularly largely the value. How can you be able to track these value changes over the years, so that if you are buying a second-hand used or a used car from somebody, can you be able to follow up and see the history of that car? Yeah, the history of its ownership and the history of its service. Can you be able to, on a decentralized platform? The decentralized platform is important because it won't be compromised. A centralized platform where I am just keeping a record on a book in my car, I can decide to change that. Yeah? If it is a house, and that house perhaps there was a fire, and I want to sell it to you, I can decide to delete the record that shows that there was a fire in that house. And that fire probably reduced the value of that house. Now, when we put that record or those records on a blockchain-based platform or a blockchain-based registry, what that means is any of you would like to buy that property can go to the ledger or to the explorer of that platform and be able to check all the history records, yeah? And where there is any history that has been deleted, that ledger will also show you that there has been something deleted here, and the system will make it possible for you to restore. Yeah, so it becomes impossible for an individual to compromise the system without the cooperation of all the stakeholders, or at least 51% of the stakeholders. Yeah, so there are several ways that where blockchain can be used, and I believe that we'll have an opportunity to discuss some of these ways in more details. So I have really handled just the basics to help you understand what blockchain is. So I want to move to smart contracts. Though under smart contracts, we will also see a number of things that I've talked about. I've laid foundation in the first module. For instance, okay, let me just first start by helping you to understand what a smart contract is. So a smart contract is a computer code that runs on top of the blockchain, containing a set of rules under which the parties to that smart contract agree to interact or transact with each other. Let me just break this down because it's really an interesting technology. The first person that talked about, or rather created smart contracts that we know, as we know it in the blockchain industry, is a guy known as Nick Szabo. Yeah, and you could probably check online and research about the history of smart contracts and how they have grown over the years. But I want to use a conventional example to help you understand what a smart contract is. So I don't know whether you've ever used an ATM, an automatic teller machine, whether you've used an AVM, an automatic vendor machine, an AVM like if you go to some of the airports, if you go to the Delhi airport, if you go to airports like Changi Airport in Singapore or Dubai Airport, one thing you realize is that they have some at certain points they have the automatic vendor machine where you can put in money and select what you want, whether you want a soft drink or you want some snack, and that machine is able to interact with you and give you the exact item that you have selected. Yeah. If you do not put in the sufficient amount, it will not be able to give you the item that you select. If you go to ATM to withdraw some money, you can be able to interact with that ATM without anybody helping you. All you need to do is put in your card, press in your PIN. Once you press in your PIN, press in the amount you want to withdraw, then the system is able to process that. Yeah. So just imagine you interacting with a wall, and the wall is able to give you whatever you need. Yeah. So that is a good example of a smart contract. So what has happened? So there are instructions or rather a program that has already been put into this ATM, and this instruction has been, this instruction or these rules goes this way, that if Benjamin comes with an ATM and he puts in a correct PIN number, then if he wants to withdraw a certain amount of money, check if he has enough balance. If he has enough balance, give him the money. If he doesn't have enough balance, do not give him the money. Yeah, tell him this way. Tell him he has insufficient balance. This is one of the simplest ways to understand a smart contract. So smart contract is not something out of this world. Now, the problem with conventional smart contracts or conventional systems like ATM that works with the smart contract model is that they're easy to compromise because they are centralized. The instructions or the set of rules that have been created and put into this system can always be compromised. Somebody would come and hack the ATM, yeah, so that when he enters his ATM card, I mean, the system will just start to vomit some money, yeah, without him even having to have balance, yeah, a sufficient balance. So they can easily work, sometimes an insider job where coordination between some people inside the bank, they work with certain people outside and to be able to just compromise the system. So as we talked about it in the first slide, or in the second or third slide, centralized systems have what we call a single point of failure. Now, when we code this set of rules on a blockchain smart contract, yeah, or rather on a blockchain system, we now enjoy the benefits of blockchain, which includes the decentralization, the transparency, and the immutability. The immutability means nobody will compromise or nobody will edit or change any transaction within that system without the consent of all the validators on that network, or at least the 51% of the validators on that network, depending on how that particular blockchain decides to make its consensus protocol or consensus process. But really, the smart contract is now that set of rules that is coded. Assuming I want to sell you a piece of land. Now, what we'll do is we simply put in the details of the land, which includes the title deed, the land title deed, is put in on the other end, the person who is selling the land. Now, on this end, the value or the price of this piece of land. Then, on the instruction or the set of rules, it can be indicated that if the person selling the land provides this documentation, it provides a valid title deed, it provides a valid maybe map of the location, provides a number of documents, maybe a document from the surveyor or a valid document from the government office. If the seller provides all this documentation, and that is verifiable on the blockchain on the other side, then on this side, the system should automatically execute that contract or automatically enforce that contract, thus releasing the funds from my wallet to the seller of the land, and then releasing this, the documents from the seller's account directly and transferring them to my account. And then recording that transaction on the blockchain that the new owner of this plot number, this in Nairobi or in India, is now Benjamin Arunda. That transaction becomes automatically executed on that blockchain platform. Now, I believe that you understand now this concept. Now, right now, most jurisdictions still have not made it easier for smart contract-based legal documents to be executed. Yeah, but in future, what will happen is transactions, because we are increasingly growing in the digital economy. With the metaverse coming, meetings being done in the metaverse, Web3 coming, growing in adoption, and all these blockchain applications and other emerging technologies. The digital economy is growing, which means transactions will largely happen online. Now, these transactions mean, this means that the government will in future provide regulations to make it possible to even transact legally, legally, and develop legally recognizable documents using smart contracts. Now, a quick one, this is the example that I've just given about me selling I've given an example of me selling a piece of land, but now this is an example of where you are selling a piece, you're selling a car, where we have smart parking garage or smart parking garages, where I want to buy a car from you. We set up a smart contract. Your car has a digital hash ID on the blockchain, and that hash ID connected to that blockchain is capable of locking and unlocking that car. Now, when we transact with you on that smart contract, you can be able to put in the IDs or the valid documents belonging to that car on the other end of the smart contract. And on my end, I put in the money that is worth that car, whether it's 20,000 euros or 20,000 pounds. Now, on my end, once I put in the money, now the instruction on the smart contract says, if the seller meets these qualifications, and if the buyer meets this qualification, then execute this transaction. Enforce that contract. So if the seller provides all the documents, and this is something that we cannot work only with blockchain alone. It will need to work with some AI where there is an external, what we call Oracle, or an external smart Internet of Things system that links the car to the blockchain. It is able to check the car, whether the car is functional, whether the car is working properly, and it's able to give feedback to the smart contract. And if everything is okay, it is able to automatically execute the transaction without the buyer and the seller ever meeting physically. So the owner of the car would just need to go to the smart garage where the car is parked and be able to, using the blockchain ID, to be able to access or unlock that car and go home with the car. In this way, we have eliminated the third trusted party, the trusted third party who we normally use whenever we want to buy an asset, such as we mostly use valuers and we mostly use lawyers. In a land, we use a surveyor and others. So what smart contract seeks to do is to reduce the intermediation, to reduce the number of intermediaries of the trusted third parties that you will need to use for you to transact. Then why trust a smart contract code? A smart contract code is as good as the integrity of the code. So if the smart contract is not properly coded, if the person who makes the smart contract is an amateur programmer, is an amateur blockchain developer or a smart contract developer, and fails to put in the required security measures, then that smart contract can be compromised. That's why we see in the industry today, certain blockchains being hacked. Sometimes they exploit what we call the bridges, the blockchain bridges, or simple blockchain smart contracts to hack certain cryptocurrencies. So the smart contract code is as good as the integrity and the quality and the veracity of that code. So you need a good a smart contract developer to develop that code. After developing that code, you need to take that code through an audit process. That audit process is able to then be able to see whether there are any vulnerabilities that can be sealed on that smart contract, any loopholes in the code that can be sealed on that smart contract. Second, why smart contract code is better than using a trusted third parties is that trusted third parties are always easy to compromise. What do you need to do to compromise a trusted third party? As the buyer, I may just need to maybe compromise your lawyer, give your lawyer some bribe, and then your lawyer will now give a wrong, maybe a valuer. The valuer now will now give a wrong valuation, yeah? Maybe give a low valuation of that particular car. Or the lawyer may now, when I compromise the lawyer may end up now not executing or not leading us to the execution of that particular contract. But code has no emotions, provided you have programmed or set up, put in the set of rules that is required with proper code, proper language, then the code will be able to execute as required and when both parties meet the set rules without any emotions. Now, consensus protocols, just a brief about consensus protocols. This is something that I've also mentioned. Consensus protocols comes from what we call the Byzantine generals problem, yeah, also known as the double spending problem. Now, the double spending problem is a historic challenge in computer science, and the challenge is this: if we are transacting digitally, if I want to send you digital money, like for instance in Kenya we use M-Pesa. If I want to send you M-Pesa, normally what happens is when I receive M-Pesa, I just receive a message, a text message, telling me that you've received this particular amount of money from this person. Now, I can now take that message, go with it to an agent, and be able to withdraw that money in hard cash. Now the problem is, if there is no third party in the middle, I can just send you a message, a normal text message, without using the app that looks the same as the message that is genuine, and you can think that I've actually paid you the money. Yet I just sent you a text message. With that, it becomes very easy to compromise the process of validating the transactions, or the process of approving or authorizing the transactions. So that's why blockchain is a big thing, because the reason why it has been difficult for many years to be able to transact digitally on an online platform is because where two people are transacting, there is always lack of trust. You cannot 100% trust the other person. That's why you need a bank. That's why you need a lawyer. Whether it's your brother, sometimes whether it's your relative, sometimes you still need to use a lawyer. Sometimes you still need to use a surveyor. Sometimes you still need to use a bank, which means if you're sending me the money has to go through the bank. Then the bank gives me a paper, and then they tell me, we will redeem this paper based on now central bank's word. This paper is 500 shillings. We give you our word that anywhere you go with this 500 shillings, we will be able to redeem it. We will be able to give you the value of this 500 shillings or the $500. Yeah. Now, without solving that problem, it becomes impossible for two people to actually interact or transact without a third party or without a trusted third party. That's why this problem needed to be solved. Now, how has blockchain solved it? Blockchain now use different models of consensus protocols. For instance, in Bitcoin blockchain, they use what we call proof of work, where for you to validate transactions, there has to, the nodes or the participants, they have to complete a certain or solve as a complicated mathematical algorithm solve a certain mathematical problem for it to be able to validate. So you have to complete some work. That's why it is proof of work. You have to prove that you've done some work, yeah, for you to actually validate the transaction. So there are other examples of proof of, and I hope I have highlighted some in this in the coming slide. Yes, you can see a list of examples of consensus protocols or consensus algorithms. We have proof of work, which is really the most popular today, is the most expensive because it uses a lot of energy. You need to set up a mining rig, which is expensive to buy. It uses a lot of electricity because you need a lot of computing power for you to solve that algorithm. Now, once you solve that algorithm is when you can be able to validate that transaction. Now, recently, there was an event that happened a few months ago called the merge in the Ethereum blockchain. The merge where Ethereum moved its blockchain into a different consensus protocol called proof of stake. Proof of stake is where you have to prove that you are holding a certain amount of a coin or a certain amount of authority for you to be allowed to be part of decision making. For you to join the table, you have to prove that you're holding a certain amount of Ethereum, yeah? And you have to stake those Ethereum. So once you stake those Ethereums, that becomes your proof, and that's become your authority, and that makes it possible for you to actually transact within that platform, or rather validate transaction. Now, there are others. Any blockchain can come up with their own consensus protocol, whatever you think it will work for you, or will some use delegated proof of work. I think Dash Digital Cash or Dash, the cryptocurrency known as Dash, uses a delegated proof of stake consensus protocol. Then we have proof of importance. We have proof of stake velocity. We have the utilizing the computational power. There, I mean, people have come up with different types of consensus protocols. All of them just showing the process that they want, the validation process that takes place within those blockchain networks. Yeah, for you to validate a transaction, what do you need to do? So I think I have talked about the consensus protocol or the proof of work. So I may not really go through this much again. A delegated proof of stake. As I have mentioned, delegated proof of stake is whereby now it is proof of stake, but now a few people have been delegated. For instance, if the community is made up of 1,000 people, we can delegate 10 people, yeah, who have shown proof of stake, yeah. We can delegate 10 people to actually show that proof of stake and be part of the validation process. So these 10 people are the ones that will validate transactions, yeah. We can decide to delegate to 100 people. I mean, it can be any number depending on the amount of community and depending on how the creators or the developers want the consensus protocol to work. Then another thing, as we wind up that segment, is crypto mining. Now, crypto mining is what I've talked about in when I was talking about proof of work. What we call Bitcoin mining is actually the consensus process, yeah, the process of validating transactions. The work that has been always been done by a trusted third party is now being done by computers, or what we call miners, or what we call nodes. They are validating transactions. Now, for them to validate these transactions, they have to complete a certain task. Yeah. In the Bitcoin blockchain, it is proof of work. So you have to complete a particular task using very high computing power. But once you complete that task, you are able to validate that transaction, and that transaction actually now happens. So we have steps like transactions are bundled together in what we call a block. Miners verify that transactions within each block are legitimate. To do so, Miners should solve a mathematical puzzle known as proof of work problem. It's a complex mathematical problem. Then our reward is given to the first miner who solves each block's problem. Then verified transactions are stored in a public blockchain. Yeah. So these blocks, that's why we call it blockchain. Blockchain means it's a chain of blocks, and within each of these blocks are a bunch of transactions. So transactions are verified and put together. A number of transactions put together, then blocked, then chained together, then hashed. Yeah, and they are hashed in a way that the first transaction, which is normally called the genesis transaction, has a relationship, sort of a genetic relationship with the transaction 10 or transaction 11 or transaction 20. So for instance, in the Bitcoin blockchain, for you to hack transaction 10, you have to hack transaction 1, the genesis transaction. Yeah, you have to hack the transaction, the first transaction that ever happened. Yeah, because each transaction that comes next contains some genes of the past transaction. So all of them are connected together. So imagine somebody wants to disconnect you from your genes. Today, if you took a DNA test, you will realize that you have genes of your father, you have the genes of your grandfather. There's some genes that go as back as or as far as your great-grandparents. Now, if I want to disconnect you from your genes and deny you the blood connection in your family, I would have to hack your genetics. I would have to change your genetics and disconnect your genetics, not right from you, but starting from your great-grandparents. I don't know which, I may have to go several years, which makes it then very difficult and almost impossible, actually impossible for that matter. So far, I think we have reached about 19 million that have already been mined in the Bitcoin blockchain. Yeah. So the mining continues. Every 10 minutes, there are new blockchain Bitcoin that are added into the blockchain, into the Bitcoin blockchain. But I believe you'll have this recording, and you can be able to go through this as well slowly and be able to highlight on the key points of that. So lastly, very quickly, within 5 minutes or less, I want to just give you basics, very sharp basics about wallets. And this is something that I've already covered. So I'll just be repeating it in a little bit more detail. Yeah. And this is to talk about wallet, cryptocurrency wallets. You cannot be able to interact with the blockchains if you cannot interact with a blockchain wallet or a cryptocurrency wallet. So a blockchain wallet has 3 important things that I would want you to understand or to master for you to be able to interact with the wallets. 1, the public key. 2 is the private key. And 3 is what we call either a mnemonic phrase or a recovery phrase. A recovery phrase, I'll just explain it in a few minutes. So a cryptocurrency wallet is a software program that stores private and public keys and interacts with various blockchains to enable users to send and receive digital currency and monitor their balance. So it's simply like your bank account. You can be able to access it if you have mobile money, if you have a mobile access to your bank account. You can be able to see all the transactions that you've ever done by just accessing maybe a mini statement or getting your bank statement. You can be able to access all transactions. And you can be able to execute a transaction within that wallet. So that simply is what a cryptocurrency wallet. This is where you start or complete any cryptocurrency transaction within your wallet. So I believe I've talked about the public key. So for important thing to master about public keys, a public key is what helps you to receive transactions, while a private key is what helps you to spend whatever you have in your wallet. So you cannot spend any money in your wallet if you do not have access to your private key. Yeah. So if I get your private key, I can be able to spend money that is in your wallet. Yeah, so private key is, as the name suggests, it is private only to you. So just quickly giving a number of examples of cryptocurrency wallets. We have software wallets, we have online wallets, we have hardware wallets. Yeah, software wallets are the most common, where we have things like what you call I don't know if you've used Trust Wallet, but there's one called Trust Wallet. There is the blockchain wallet. There is a number of others like software wallets. There are a long list of software wallets that you can be able to download online, yeah, and use for multiple currencies, like the Coinomi, which is a multi-currency wallet. Then online wallets. These software wallets, of course, are also online wallets. Some of them you can access on web, like the blockchain wallet. You can be able to access it on web without having to download the wallet. Hardware wallets, these are wallets that some of them look like a flash stick. They are offline, so you don't transact with them online. You can store your cryptocurrencies offline, which means they become more secure. Yeah, and a good example is Ledger Nano. There's what we call Ledger Nano, there's Trezor, and there are others as well. And you can be able to access this. You can be able to purchase any of these on Amazon or some of those e-commerce platforms. Then there's also Paper Wallet. It's also a cold wallet. So hardware wallets and paper wallets are what we call cold wallets. Software wallets and online wallets are what we call hot wallets, which means they're accessible via internet or via online platforms. Now, this is just an example of a multi-currency wallet, or rather a Coinomi wallet. And this is sending and receiving BTC. I already showed you this when we went through the process of transacting or sending Bitcoins from person A to person B. And you can be able to interact with that later on. I've also talked about already hot versus cold wallets. Hot wallets are not so secure because they are online. Sometimes they can be compromised. If somebody compromises your computer or using malware, somebody can be able to get you to give up your private keys, or get you to give up your recovery phrases, and they can use that then to access your wallet and then steal your money. And that's why people lose money sometimes when they have stored them in exchanges, when they have stored them in certain online wallets. Offline wallets, or other cold wallets, like paper wallet or the hardware wallets, are not accessible online, which means it is more secure because nobody can access them online, then become more secure. Many of them now, also this depends also on how good is the creator of the hardware wallet, of the cold wallet. So you have to really also check the reviews of that particular cold wallet to be sure that you're buying a good wallet. And these are just some of the pictures of these wallets. There's Safety, there's KeepKey, there is Trezor One, there is Ledger Nano S, which is, in my view, really used by most people, even in this part of the world. We use Ledger Nano S. Now, lastly, I believe this should be the last slide. How to secure your wallet. Never share your private keys. Yeah. Since the fall of FTX recently, a phrase that has been going around that is really famous is not your keys, not your funds. Not your keys, not your crypto. So if you give up your private keys, you have given up your cryptocurrencies. You have given up your funds. So you must ensure that you keep privately your recovery phrase and your private keys. Do not give up that to anybody. Store them securely and privately. Be careful of online sites. Do not just click links that you receive on your email. Some of them can be malware, and some of them can lead to compromising your wallet. Avoid using public Wi-Fi when accessing your wallet. Yeah, you can use mobile data bundles instead of accessing them using public Wi-Fi, because some of those can be able to steal or pick up your wallet, pick up your passwords and be able to access your wallet. Use multi-signature wallet to protect your wallet. Okay, multi-signature is often used by when you're storing money and that same money is owned by maybe 2 or 3 people. For instance, if it is a couple, two of you, a wife and a husband, you can decide to have a multi-signature wallet where both of you need to sign for you to access that particular wallet. Then paper wallets, keep your keys private, your private keys in different offline locations. Yeah. Keep one that you're safe in the bank, depending on how much is in that wallet. If it is a significant amount, you can keep it in a safe. Then secure well your recovery phrase and wallet passwords. All right, that marks the end of my presentation. Thank you so much. Here, the first question I see here is, will data engineers play a role in maintaining these networks? If so, what will data engineer need to do to build and maintain these networks? Yes, data engineers will play a role to maintaining these networks. Now, these Bitcoin transactions or blockchain-based transactions will revolve around data. Therefore, the role of blockchain-skilled data engineers. So not just any data engineer, but he must be able to interact with blockchains. Yeah, he must have the skill of interacting of how blockchain transactions happen. Yeah, and be able to know if it is a blockchain architecture, how the transactions flow from one part to the next, and be able to actually make a decision with regard to how to secure that data. Let me give you a good example. For instance, a bank that needs to set up a blockchain to provide maybe a KYC or know your customer system based on the blockchain, yeah, that they should use then to onboard customers. Now, data system, because it is a bank, the data that they involve may be so sensitive. Same to when it is a healthcare, yeah, when it is a hospital, the data may be so sensitive. Therefore, this particular data engineer who is knowledgeable in blockchain as well will help these people to make the right decision on the architecture of how this data will interact, yeah, to ensure that this data is secure. Then the second question is, how is the ledger made at the start of any blockchain? E.g., at the origin of the blockchain, then modifying the ledger is easy at source. Only one ledger exists at source. How is the ledger made at the start of any blockchain? Okay, how is the ledger made at the start of any blockchain? So this is what happens. For instance, for the Bitcoin blockchain, yeah, the first transaction in that ledger was the Genesis transaction that happened in 2009. Yeah, the first Bitcoin that was mined. Yeah, so the first block that was mined that I think contained about 50 Bitcoins that came into the blockchain. That forms the first ledger of transaction. Now, how the first ledger is created depends on the consensus protocol of choice. Yeah, whether if it is proof of work, then who would have, or what will be the first work, the first task that will be completed? If it is validating a transaction of 50 Bitcoins, then that transaction becomes the first transaction on that ledger. Yeah, I hope you're getting that. If it is, for instance, talking about land transactions in a land registry of title deeds, or a registry of a blockchain-based registry of title deeds, then whatever transaction between somebody selling a land or putting in or feeding in that data into that ledger becomes the first transaction. So it is the first transaction that is entered into that ledger becomes the first transaction in that ledger. Yeah. Which blockchain architecture does Solana belong to? I believe Solana belongs to. I believe Solana is a public blockchain. Yeah, I believe Solana is a public blockchain because Solana as well has an architecture that supports smart contracts. Yeah, is blockchain a framework or is there more to it? Yeah, blockchain is largely a framework. Blockchain is a framework. Let me tell you something to add on that. Blockchain can be as complicated or as complex as the blockchain developers decide. Yeah, and that's what we see blockchains in this age, how complex they are. Let me just help you understand. Here is where you find a blockchain, which is a smart contract, a complicated smart contract. Then they link it through a bridge, maybe a blockchain on Ethereum. They link it through a bridge to a Polygon or a Polkadot blockchain, yeah, or a Solana blockchain network. So, and then this blockchain also interacts with a particular Web3 platform. So a blockchain can be as complex as the blockchain developers decide to make it, depending on how they want to solve the problem they're looking to solve with that particular blockchain. I am interested in creating education certificates and digital rights. What blockchain would you recommend? For a digital, for creating education certificates and digital rights, I think this one, the best one you can use is the Ethereum blockchain. Ethereum blockchain is really good for that. But if you're just testing, the fees may be high, the gas fees may be high. So an alternative may also be the Binance smart chain. But number one recommendation for me is always the Ethereum's Ethereum blockchain. Any example of how blockchain is used in record keeping in healthcare? There is a company known as MedRec. I think it's MedRec, where MEDREC is a company it's providing medical records. Let me give you an example because we want to understand how it is used in record keeping in healthcare. Take, for instance, in Kenya right now, or whatever country you are in right now, you can think of. I am in Nairobi right now. So assuming I have gone to the hospital and they have tested me for a particular, they have tested me, maybe I have maybe some fever, yeah, or maybe some fever, and I need some medication. They test me, they enter my records into their hospital records, yeah. I start medication, and they tell me I should be back for further medication or for further checkup on a particular day. Now, because I don't live in Nairobi, maybe the next checkup date finds me somewhere else, maybe 500 kilometers away from where I was, from Nairobi. Now, I can't go to the same hospital. Now, I have to go to a different hospital in that location for me to continue that medication. Yeah. Now, when I go to that hospital, it is a waste of time if they have to start from zero because they can't access the records, my records in Nairobi. Now, if there is a common blockchain record system, if this is a chain of hospitals, yeah, assuming it is a same chain of hospitals, then when you go to that different location, the doctor in that location can be able to tap into the same data that is in that different hospital and continue your medication without being disrupted. That is really useful, for instance, when treating diseases that has continuous medication like HIV/AIDS and different others, where you have to go back to the hospital and continue medication or other. There are several different, for instance, neurological related diseases, where you have to go back to the hospital to continue medication. That syncing of data from different parts of hospitals makes it easy. And also another good example is in medical research. Medical research needs hospital data for them to do research. Now, for them to do that research, they need consent. Now, when we have blockchain hospital records or healthcare records on the blockchain, it becomes easy for these researchers to be able to get consent, because then if you are the patient, you may have an app on your system that can be able to just give you a pop-up and show Benjamin Hospital or Benjamin Research Hospital wants to use your records. Do you give them access? Do you consent to this? It can be able to make such research easier.